Today we're going to look at Section 8.1, Review of Equations of Lines and Writing Parallel and Perpendicular Lines. The first thing we're looking at is the point-slope form, which is y minus y1 equals m times the quantity x minus x1, where m is the slope and x1, y1 is a point on the line. In example 1, we're asked to write the equation of a line with slope -4 and containing the point 2, -3. Additionally, they want us to put it in y equals mx plus b form. Using our formula, the point-slope form, we plug in what we know. We know y minus a -3 is a y plus 3. If we take the -4 times the quantity x minus 2 and distribute that -4 to the x, we get -4x. And then distributing the -4 to the -2, we get a +8. Subtracting 3 to both sides, we have it in our y equals mx plus b form, and we find the equation is y equals a -4x plus 5. Example 2, we're asked to write an equation of a line through 2 points, and we're given the points 3, 0, and -5, -7. We have to do one more step in this problem. We have to find the slope, and we know slope is rise over run, so we take the difference in the y's over the difference in the x's, and we find a -7 over a -8, which reduces to just simply 7 over 8. Using the point 3, 0 and slope of 7/8, we find the equation of the line to be y minus 0 equals 7/8 times the quantity x minus 3. When we distribute that 7/8 times x, we get 7/8x. 7/8 times a -3, we get a -21/8. So our equation of our line ends up being y equals 7/8 times x minus 21 divided by 8. On example 3, we must recall that a horizontal line has an equation in the form y equals c. So if we're given a point such as 3, 4, the equation of the horizontal line that goes through that point is simply y equals 4. On example 4, we're asked to write an equation of the line containing the point 5, 6 with undefined slope. We have to remember that undefined slopes means that the line is a vertical line, and the vertical line has an equation in the form x equals the value of the x in that point. So if we look up here at our point, the x is 5, so the equation is simply x equals 5. On example 5, we were asked to write the equation of the line containing the point 2, 3, and parallel to the line y equals 4x plus 7. Recall that parallel lines have the same slope, so our slope for our equation is 4. Plugging that in with our point 2, 3, we have y minus 3 equals 4 times the quantity x minus 2. Distributing that 4 to the x, we get 4x, and the 4 to a -2, we get -8. Continuing to simplify, we add 3 to both sides of the equation, and we end up with y equaling 4x minus 5. Example 6 is we're asked to write the equation of a line containing a point. That point is 6, 7, and perpendicular to this line. We have to recall that perpendicular lines have the negative reciprocal slope. So our slope of 2 in our original equation becomes a -1/2 for our perpendicular line. We use point slope and put in our information, and we have y minus 7 equals -1/2 times the quantity x minus 6. When we distribute that -1/2 to x, we get a -half x, and a -1/2 times a -6 gives us a +3. Further simplifying by adding 7 to both sides, we find that our equation is y equals a negative 1/2x plus 10.